Kia ora whānau, welcome to my video on voltage testing. Today we're going to look at voltage testing. Let's get straight into it. If you looked at my previous videos, the first one in the series on multimeter functions, you will recognize this guy here. This is my tester that we are going to use today, and we're going to look at how do we use this to test for voltage. Now, in that video, I talked about voltage DC and voltage AC. Those are the two types of voltage that we can test for, and we're going to look at both in this video here. You can see that I have pre-prepared an extension lead here that has a standard New Zealand and Australian pattern 10 amp socket that is plugged in off screen, so that's live. And I also have a battery here, just a standard 9 volt battery. The socket that is connected to our the power in the wall, which is 230 volts AC by convention within New Zealand, and this one here, the battery, that's going to provide me with a DC voltage. All batteries provide direct current, and I would also use direct current if on a DC power supply in most electronic devices, things like that. But for today, to demonstrate DC voltage, we're going to use this battery here. So let's have a look. We'll start with the socket. That one should be 230 volts AC. Because it's 230 volts, I need to select the correct range on the volts AC section here. Well, it's certainly higher than 2000 millivolts. It's higher than 200 volts, so I'm going to go straight to the 750 volt range. What I want to do is plug my meter leads, 1, 2, into two of the outlets on the socket, and we will see immediately we've got a buzzing. My meter is physically vibrating. We've got a beep, and we've got a light lighting up there where it says high V, which means high voltage. So my meter here is giving me several warnings that I've just plugged into something that is live at a dangerous voltage. And you can see on the screen there it says 237 volts. Now, I said we would get 230 volts out of our power here in New Zealand. That's more or less. So 237 volts, that's on the high side, but it doesn't worry me too much. I'm okay with that. What this is mainly telling me is that my voltage source is live. I'll just unplug that to get rid of that annoying beeping. Your meter may or may not have those functions, the vibration, the light, or the beep, or it may just display the value on the screen there. So looking at our socket there, you would have noticed that I've plugged into the top two, but we have this third one here, which you may already know is earth, or if you don't, now you do. Let's have a quick look at what those three sockets are and how that affects my voltage testing. So you can see here I've got a couple of pictures. One is just a bird's eye view of the socket that I just showed you. There you go, look at that. It looks exactly the same as that one. And here we have a similar view of a wall socket, typically that you would find in any house or building within New Zealand or Australia. And I've labeled those there with which terminal is which. So the one on the top left is our phase. The one on the top right is the neutral. And the one in the bottom is earth. And I've labeled them with the colors that you would typically see for the wires there. Phase is red, neutral is black, earth is green, or green and yellow. And the same on this socket down the bottom here. Phase on the left, neutral on the right, earth on the bottom. So when that comes to testing, what do I need to test? Well, if you look over on the right-hand side here, you will see that we have phase to neutral should be 230 volts. Phase to earth, 230 volts. Neutral to earth, 0 volts. Let's not go into the reasons why those values need to be there, but those are what I am looking for. And when I'm doing voltage tests, particularly if I'm testing in isolation for my own safety, I really need to make sure that either all of those voltages are there to show me that the socket is correct and live, or that none of those voltages are there to show me that the socket is dead and therefore safe for me to work on. So if we just pop back to our lead here, that would mean I need to test phase to neutral. That should be 230 volts. Phase to earth, that should also be 230 volts. And neutral to earth, which should be 0 volts. then if neutral to earth is not 0 volts when the socket is live, something has gone terribly wrong. There is a very dangerous condition present in my building. So we need to do something about that immediately. So let's just have a quick look. We'll just repeat the first test that we did, which was phase to neutral. And we see there we have our 237 volts. Fantastic. So let's go phase to earth. As we saw on our diagram, that should also be 230 volts. So I plug that in, phase and earth, 237. Great. And the last one will be neutral to earth. And as I said, that should be 0 volts. If it's not, something is wrong. I'll plug that in there and I'm getting, well, it says 2 volts. But in this case, 2 volts doesn't really mean anything. Even if I unplug my meter, it's still showing something. So 2 volts is satisfactory. In this case, I'm certainly getting no beeps, no vibration from my meter. So if it says 1 or 2 volts when I test between neutral and earth, that's okay. So that tells me with those 3 tests that this socket and the power that it's connected to is functioning correctly. Let's move on to DC voltage. I'm going to turn my meter now around to volts DC. And again, I'm looking at the range 2000 millivolts, 200 volts, or 1000. And if I look at my battery, it helpfully says right there on the side, 9 volts. Most of you will recognize this little square battery as a 9-volt battery. So I'm going to choose the 200 volt scale. It's more than 2000 millivolts, so that's no good. It's certainly nowhere near 1000, so 200 will be the right one. So I change round to the 200 volts DC scale, and I'm going to do the same thing. I'm just going to put my probes on the 2 terminals at the top, and I would expect to see, well, 9 volts, right? It says 9 volts on the side, so let's have a look. We can see the meter goes to 9.6. That's pretty good. You will find that most batteries, if they are charged up, will be a little bit higher than the labeled voltage. If it was less than 9 volts, if it was a little bit less than 9 volts, that would probably be okay. That's indicating that the battery is used, but probably okay. Once it starts getting perhaps below 8 volts or 7 volts, then that battery is probably no good to me. If it was showing 0 volts, then the battery is undoubtedly flat. Let's just look at one thing with the DC voltage in particular. If I switch my meter leads over and put them on the opposite sides, now you see it still says 9.6 volts, but it now says negative 9.6 volts. That's because I've got my negative lead on the positive terminal and my positive lead on the negative terminal. Because DC is polarity sensitive, that is, the current only flows in one direction, so one of these terminals is always positive, one of them is always negative. That means that it will detect whether my voltage is positive or negative. If I'm just measuring a battery, it doesn't really matter. What I need to know is it 9.6 volts between those 2 terminals? And I find, in fact, yes, it is. In some electronic applications, you may need to be able to test whether something is positive or negative voltage, typically with respect to earth. And so that it would be important for me to get my meter leads the correct way around. But as I said, if I'm just testing my battery, either way, it's still telling me there's 9.6 volts. It doesn't matter whether it says positive or negative, although it's a good habit to get into to put my red lead on the positive terminal, black lead on the negative terminal, and it tells me 9.6 volts positive. One last thing to think about with respect to voltage testing is that voltage testing is between 2 points. A voltage only exists between 2 points. So I can't, for example, just pop back to our battery, I can't use one lead and put it on there. You'll see, I get no reading. Even though we know, well, that terminal's 9.6 volts, right? If I go back to my AC voltage and I put one of my leads into the phase side, we know that's the live one, still I get nothing. It's not until I plug my other lead into something else with a different voltage that it will show me any reading. And that's really important for safety reasons. I can't get a reading off a single lead. I must be testing between 2 things. And we also should note that if I test between 2 things that are the same voltage, this is going to show me the difference between them. If I test between 2 things that are live at 230 volts, my voltmeter will say 0 because it's detecting 0 difference between the 2 probes. That one's 230, this one's 230, the meter says 0. So we really need to know that when we're doing our voltage test, one of my meters is plugged into either earth or neutral, which gives me 0, and then the other one should be able to measure the phase value. Remember that voltage is potential difference. This is why, for example, a bird can sit on a very high voltage power line and not get a shock because it's only connected to one voltage. If it somehow became connected between that line and earth, 0 volts, then it would get a very large shock very quickly. But important safety note for our testing that I must be testing between 2 different voltages to get a reading. If I test 2 voltages that are the same, it will tell me 0. All right. That's all we need to cover today, very briefly. We are going to have another video on voltage testing, and that's going to be using the prove, test, prove method for isolation, which is a really important methodology that we use in the electrical industry in order to prove and confirm that something is dead before I work on it. So if you want to get a little bit more into depth into how we do voltage testing, particularly for safety and isolation, that's the next video to watch. I will see you there.